Good afternoon, sir.
Good afternoon. Is this slide visible?
No, sir.
No,
No, sir, the
sir.
folder is visible.
Okay. Now,
Yes, sir.
now it's visible. Okay.
Yes, sir.
Okay. Thank you. So we have already learn about this architecture, basic introduction, 8085 microprocessor. So today I'd like to discuss about the architecture. Last day I have discussed the pin details, these pins, pin diagrams. No, this one. Sorry. Uh, so the block diagram, it is the block diagram, architectural block diagram of 8085 microprocessor. So it is generally available as a 40 pin IC, as I have told you earlier, with the 5-volt power supply, dedicated power supply, and the maximum frequency that can be operated, that is the 3 megahertz frequency, but it is varied according to the various version. Okay, so the total range of frequency, operating frequency, will be 3 to 5 megahertz, 3 megahertz to 5 megahertz. uh, so the 8085, that is called an 8-bit microprocessor, because it's ALU, it's ALU, arithmetic logic unit. This one is 8-bit in size. Okay, so how can you identify a processor is of 8-bit or 16-bit or more than this? By checking the size of ALU, arithmetic logic unit. Okay, if it is 8-bit, then it is an 8-bit processor. If it is 16-bit, then it is a 16-bit processor. But in maximum, so in books it is written, in maximum books it is written that it depends on the data length or data bus. Okay, no, that is wrong. It's not about the data bus, it's all about the ALU circuit. Okay, so 8085, that is so it is used to address maximum 16 bits of address is used. So it can address up to the power 16, that is 64 kilobytes of memory. Okay, to the power 16, because 16, that is the number of address lines. I think I have already told you how can you calculate the total number of memory, total memory size, that is 2 to the power number of address lines. If the address lines are 16, then 2 to the power 16. If the address lines are 20, then 2 to the power 20. So according to the size of the address bus, total memory can be calculated. Okay, so here for 8085, the address bus is 16 bits in size. So that's why the total memory space is 2 to the power 16, which is equivalent to 64 kilobytes. Okay, now this architecture, basically, it contains 5 functional units. Number one, that is the arithmetic and logic unit, which is ALU. Then general purpose registers. Number 2, general purpose registers, B, C, D, E, H, L. These are. Number 3, special purpose registers. Okay, special purpose, under special purpose register there is an accumulator, flag register, program counter, stack pointer. All these are special purpose registers. Number 4, that is the instruction register and decoder. Register and decoder circuit. And number sorry number 5, that is the timing and control unit. Okay, so it has 5 functional units. The first one is the ALU. Second is the general purpose registers, B, C, D, E, H, L. All these are 8-bit registers. What is the function of register? To store the data. Okay, each register function is to store the data. So how much data will be stored in one register? 8-bit data. 8-bit data. Okay, because the size of each register, whether it is B register or C register or D or E or H or L, all these are 8-bit in size. So maximum 8-bit of data can be stored. And how these registers can be made? By using the flip-flop. So to make an 8-bit register, you need 8 flip-flops, because one flip-flop can store 1 bit at a time. So to store 8-bit of data, you need 8 flip-flops. Okay, and using these 8 flip-flops, one can create the register. Okay, so such type of flip-flops are used in these registers, and we have B, C, D, E, H, L, these general purpose registers. And number 3 unit is the special purpose registers. Under this special purpose registers, accumulator is there, flag register is available, program counter register is available, and stack pointer register is available. Accumulator is 8-bit. It is an 8-bit register. Flag register, it is also an 8-bit register. Program counter, that is 16-bit register, and stack pointer, that is also 16-bit register. Okay, number 4, that is the instruction register and decoder circuit, and number 5, that is timing and control unit block. So these are the 5 functional units. So I would like to discuss one by one. So next is the arithmetic and logic unit. Now, all of you heard about this ALU, arithmetic and logic unit. Basically, it is the circuitry that performs the actual numerical and logical operations. Okay, like for example, addition, subtraction, increment, decrement, comparison. These are the arithmetic operations possible in the 8085 microprocessor. And the possible logical operations are like AND gate operation, OR operation, exclusive or XOR operation, that is complement operation, basically not operation. Okay, so these operations can be performed in 8085 microprocessor. Okay, so the ALU of the 8085 processor is called the accumulator oriented ALU. Remember this term. ALU of 8085 processor is called accumulator oriented ALU. Why? Because as one of the data used in arithmetic and logical operations must be stored in the accumulator. Okay, like if you want to add 2 numbers, so one data or first number should be stored inside accumulator, and second number that can be stored in any register, either B register or C register or D or E, H, L, or it is coming from the outside memory location. Okay, but your first data byte should be coming from the accumulator. It should be stored inside accumulator. Okay, now for any logical operations, for AND operation, you need 2 numbers. The first number should be stored in accumulator, second number from anywhere. Okay, that's why all the operations are based on arithmetic and logical operations are based on ALU, accumulator oriented operation. Okay, so that's why one data that must be used in that is used in arithmetic and logical operations must be stored inside the accumulator register. The other data that is taken from either memory location or from any other register. Okay, and After that, the results of the arithmetic and logical operations are stored in the accumulator automatically. Okay, accumulator automatically, by default it is stored inside the accumulator. So every time accumulator gets changed, because at first input will be stored, and when the operation is performed, the output will be stored inside the accumulator. So every time accumulator gets changed. Okay. If the operation needs only one data, like for complement operation, for not operation, you need only one data, so that data must be stored inside the accumulator. Okay, so all the operations are basically in 8085, most of the operations are based on the accumulator oriented operation. Clear? So that is the function of ALU also. The arithmetic and logical operations are performed here. Is there any confusion up to this one? Do you have any queries, any doubts?
No, sir.
Shall I proceed?
Yes, sir.
Okay, thank you.
Yes, sir.
So next is the general purpose registers. So as I have told you that a register is a collection of flip-flop, mostly D-type flip-flop is used to make a register with parallel in and parallel out operation basically. So a flip-flop that can only store one bit at a time. Now to store the 8 bit, you need 8 flip-flops. Okay. So here the registers are all storage areas inside the microprocessor, because all these registers, this is the architecture which is inside the IC, inside the microprocessor. So all these registers are inside the microprocessor, but they differ in the purpose of storage. Okay, they have used in different way. So the general purpose registers, these are used to store only the data that is being used by the program under execution, and also the results obtained from it. So these general purpose registers are basically user accessible through different programs. Okay, it is available to you. Huh. So register B, C, D, E, H, and L. These are the general purpose registers in 8085, and they can also be called as scratchpad registers. Scratchpad registers, because these are used in instructions to write a program. Okay, all these are your actually best friends. Okay, so you can use them in your uh, operation in different way. Okay, so basically these are available to you, these are available to the user or the programmer, okay, to store some data. Now in almost all arithmetic and logical operations, these registers are used as the second operands. Why? As I have told you earlier, that first operand being the accumulator, the second is from the either B register or C register. Suppose I want to um, perform 2 plus 3, 02 plus 03. So I need to store 02 inside accumulator and 03 inside B register, so that if I want to add them, so instruction will be given, and from and from A register, these are the buses. Through this bus or through this channel, the corresponding data will be transferred, and through this channel, the first data, which is 02, will be coming, and from B register 03 will be coming in this way, and it is stored inside the tempo register, and from tempo register it goes to the ALU, where the addition will be performed. And when this addition will be performed, 2 plus 3, the result will be generated at 05, which will be again going through this bus, and it is coming to the accumulator in this way. Okay, so basically the general purpose registers are all 8-bit registers, but they can be handled as 16-bit register as well. Okay, these are all individually 8-bit register, but they can be used to create a 16-bit register. How? By the combinations of two registers. Like you can combine B and C register. So B register is 8-bit register, C register is an 8-bit register. If you combine them, 8 plus 8, 16-bit register is created, so that one register pair is has been created, which is called the BC register pair, which is 16-bit in size. So if I want to store any 16-bit number, I can use BC register pair at a time. Okay. In the same way, there is another register pair which can be created by the DE registers. Okay, D and E. By the combinations of D and E, you can create another register pair which is called DE register pair. In the same way, another register pair is also available using H and L register. Okay, so these are fixed. These cannot be changed. Okay, you can't combine B and E register, you can't combine D and C, you can't combine H and C register, or B and L register. No, always BC register pair will be there, always D register pair will be there, always HL register pair will be there. So we have three register pairs, okay, for any 16-bit operation. So it is an 8-bit processor. Remember, it is an 8-bit processor, but you can perform some basic operations using 16-bit. Okay, so using 8-bit microprocessor, you can perform 16-bit operation also. Okay, but it has some limitations. Not all the 16-bit operations can be performed. That's why the 16-bit microprocessor 8086 was invented. Okay, but for a small system, you can use it for 16-bit purpose. That's why these register pairs uh, used. These are created in this way. Okay, so so we will discuss it later after, when I'd like to discuss the instructions. This will be discussed in details. Okay, right now you just need to remember that we have 6 general purpose registers: B, C, D, E, H, L. All these are individually 8-bit register, but for any 16-bit operation, if I'd like to perform any 16-bit operation, we can combine them. How can you combine them? Using B and C register, you can create one register pair. Using D and E register, you can create another register pair. Using H and L, you can create another register pair. Okay, so 3 register pairs are available to perform any 16-bit operation, okay, for a small system. So these are the advantages of having these general purpose registers. Okay, now coming to the third unit, which is called the special purpose registers. Now there are so these are the registers that are dedicated to a specific function. Okay, and under this category, uh, accumulator is there, flag register is there, program counter, stack pointer is there. Okay, so first of all, accumulator, like I have said already, that accumulator, it is an 8-bit register. It is a part of the ALU and is the most important register among all. So why? It is used to store 8-bit of data and to perform arithmetic and logical operations. So the output of any operation is also stored in the accumulator by default. Okay, automatically when any operation is performed in ALU, the result will be stored inside accumulator initially. Now it depends on you, it depends on the user. You can transfer, you can shift that content from that particular register to any other register or any other memory location, or you can display it into the real world, okay, using different output device. Okay, so the accumulator, that is identified as a register. Okay, and we have to use this a register in the instruction set of the 8085. Okay, so the programmer that can use it at any time to store an 8-bit binary number, 8-bit binary number. Now, being only 8 bits long, it can only hold 1 byte at a time, because we know that 8-bit, which is equivalent to 1 byte. Okay, so any previous data stored in this register, that will be that will be overwritten as soon as a new data is stored. Okay, and the 8085 microprocessor that will communicates with the input output devices, those are external to the processors, only through the accumulator. Okay, so accumulator is the gateway for any transfer operation from the internal to external. Okay, if we want to connect it with some real world system, so first if the result is stored suppose in B register, okay, and you need to display it on some LED display, okay, or some any other output device. So first you need to move the content from B to A, then from accumulator only you can send it to the external world. So so accumulator is the gateway, okay, of any transfer operation from internal to external or from external to internal. In the same way, if you want to process any input data from the external field or from the real world side, so first it will be stored inside the accumulator from the external to the accumulator, then from accumulator you can transfer the content into any register or any memory location. The next is the flag register. Okay, clear up to this much? What is the function of accumulator, and what are the register pairs or anything else? Do you have any queries? If you have any queries, any
No,
doubts,
sir.
you can ask me. Anyone else? Because you need this concept for lab, okay, to create a program. Because if you don't know how many registers and what are the functions of each registers, you can't create the logic of your program. So if you have any doubt, any queries, you can ask me. Okay. Okay, so move on to the next topic, that is the flag register. Flag register, this is a special 8-bit register. So each bit of the flag register, basically there is a, yes, this one. So okay, before going to discuss this one, just see this diagram. Where is it? Flag register. Now when any operation is performed inside this ALU, the result is generated over here and it is going through this bus, okay, through this data bus. But at the same time, when any result is generated inside the ALU actually creates certain conditions. It gives the status of the operation. Which type of status of any operation? Like in any operation, there may be a carry, may not be a carry. In any operation, the result may be 0 or may not be 0, or the result is either positive or negative. So these are the status of your operation. So these status can be reflected into here in this position in flag register. So basically these flags are changed according to the status of your operation, condition of your operation. Okay, that's why these are very special. So every time whenever any result is generated inside the ALU, at the same time the flag has been created certain conditions. Okay, flag register, using flag register certain conditions has been created so that user or the programmer or itself microprocessor can understand, okay, this is my result condition, this is my result status. Okay, so here this is, so each bit of this is the flag register. It is an 8-bit register, so this is D0 bit, D1 bit, D2 bit, D3, D4, D5, D6, D7 up to 8 bit, 1 2 3 4 5 6 7 8. So 8 boxes are there. So it is represents 1 bit. These are individual 1 bits. It is started from D0 to D7. Now each bit of the flag register is quite independent of the others. Okay, in all other registers, each bit that is part of a single binary byte value, and his each bit would have a numerical value. Okay, but the flag that is an 8-bit register used to indicate basically the status of a recent arithmetic or logical operation. Status of a recent arithmetic or logical operation. So it may be set or reset after an arithmetic or logical operations according to the conditions of the processed data. Okay, set means 1, this bit should be 1, or reset means 0. So there are 5 flags. Okay, the 5 flag bits are over here, that is from S means sign flag, 0 flag, auxiliary carry flag, parity flag, and carry flag. So these cross, these are, don't care, these are not used, so that's why it is represented, these are not used, so it represented by this cross. Okay, but only 5 bits are used, that is the carry bit, which is D0 bit, D2 bit is the parity bit, D4 bit that is the auxiliary carry bit, D6 bit that is 0 bit, and D7 bit that is for sign bit. Okay, so these are the flags which will be reflected, which will be affected by the operation. Okay, so it gives the status of your recent arithmetic and logical or logical operation. Okay, so either this bit, either this flag will be set or reset. Set means 1, reset means 0. Is it clear? Set means 1, reset means 0. So like sign flag. So basically the sign flag, it's just a copy of the bit D7 of the accumulator. Okay, and it is used for indicating the sign of the data in the accumulator. Okay, and this sign flag is set if if your data is negative, that means 1. This sign flag will be 1 if it is a negative number. And how can you identify? A negative number has a 1 in bit number 7, and a positive number has 0 in 2's complement representation, obviously. Okay, so if any, like I have given that 80 in hexadecimal number system, 80. Okay, 80 can be written in this way. Wait a minute. I need to use a word. I need to write something so that you can understand properly. Okay, suppose I have written 80. Okay. 80H, that is in hexadecimal number system, 80H. 80H. So in hexadecimal number system, it is written as written in this way. So in binary, how can you write it? What will be the content? Binary bits. Anyone? It is visible, this word?
Yes, sir, visible.
Okay, so how can you write this 80 in in binary form? In binary form, how can you write it?
So 1000.
1
Sir,
0.
1 then 7 zeros.
Yes, good. Okay, right? Okay, I need to give a gap. Clear? So 8 represents 1 0 0 0 and 0 represents 0 0 0 0, because I have told you that one hexadecimal digit which is equivalent to 4 binary digits. Okay, so 0 can be represented by 0 0 0 0, 8 can be represented by 1 0 0 0. Okay, so this is your this bit, this one, this is your D0 bit, this is D0 bit, and this one, this can be used as your MSB bit, okay, or D7 bit. So in any data byte, if D7 bit is 1, that means for a signed number operation, this is a negative number. This is a negative number. So 80, that is your negative number. Why? Because D7 bit is 1. If D7 bit is 1, then it is a negative number. And if D7 bit is 0, then it is a positive number. And if this D7 bit is 1, the corresponding sign flag will be 1. And if this bit D7 bit is 0, the corresponding sign flag will be 0. And that's why I have told you that sign flag is just a copy of the D7 bit of the accumulator result. Okay, so a negative number has a 1 in bit 7 and a positive number, a 0 in bit D7, bit 7 in 2's complement. Okay, so this flag basically indicates the sign of the number. Okay, so this is basically used in signed arithmetic operation. Okay, now coming to the zero flag. Next, zero flag, this flag. So the zero flag, it is set if an arithmetic operation results in a 0. Okay, if all the bits are 0, means all 8 bits are 0, 0 0 0 0 0 0 0 0. If the result is all 0, all bits are 0, at that time only this flag will be set. Okay, set means 1, and except this 0 result, for all other time, okay, this will be 0, means reset. So when this 0 flag will be set, if the result is 0, and when this will be reset, when the result is non-zero. Clear? Next is the carry. Next is the carry flag. Now what is the function of this carry flag? The carry flag, basically it is the extra bit, means in suppose in any operation the result, so this is if you want to add two 8-bit numbers, if you want to add two 8-bit numbers, the result may be more than 8-bit, maybe. So what does it mean? There must be some extra bit. More than 8-bit means the 9th number bit is your carry bit. It is called the carry. So there may be carry. So if any carry is generated in your operation, at that time only this flag will be set. Set means 1. And if there is no carry in your operation, in your result, so it is reset, means 0. So when this carry will be 1, when in any arithmetic and logical operation, if result generates a 9th number bit, then it is called as carry, and at that time the carry flag will be set. Otherwise, if no carry has been generated, then carry flag will be reset. Okay, now the parity flag. Parity flag. So basically this parity flag is set if the content of the accumulator after an arithmetic operation has an even number of ones. Otherwise the parity flag is reset. Okay, and using this principle, it is set for operation in the even parity mode. Okay, so if there are even number of ones, then only the parity flag will be set. Parity flag will be 1. Otherwise If there is odd number of ones, parity flag will be reset, means 0. Okay. Um, like as for in the last example 80, which I have written here. Here, how many ones are there? Only one. That means parity flag will be 0. If it is written in this way, 1110 1001, okay. So okay, now, so how many ones are there? 1 2 3 4. So there are even number of ones. That's why if any result is generated in this way, at that time the parity flag will be set, means parity flag will be 1. Otherwise, if this type of result, if this has happened, then 1 2 3 4 5 number of ones is an odd number of ones, so that means the parity flag will be reset. Clear? Next is the very important, that is the auxiliary carry flag. Auxiliary carry flag. 1 minute. Okay. So auxiliary carry flag, basically when this will be set, or this will be reset, in which condition? So auxiliary carry flag is set when an auxiliary carry is generated in the process of an arithmetic operation in the accumulator. So what does it mean? That means when a carry results from bit D3 and passes on to bit D4. So that means it is a combination of two nibbles, one 8-bit value, that is a combination of two nibbles, 4-bit, which is equivalent to one nibble. Okay, so 10110011, that means it is D0 bit, next is D1, then D2, D3, D4, D5, D6, D7. In the same way, the second number is also D0, D1, D2, D3, D4, D5, D6, D7. Okay, so if any carry is generated, so after addition, if any carry is generated only in D3 position, and the carries passes on to the next bit, D4 bit, at that time only the auxiliary carry flag will be set, because this is the higher bit of one nibble and this position is the lower bit of second nibble. So in